Hello and Assalamualaikum. My name is Nasuha and today me and my group will be presenting about our assignment 1 for Intelligent Control System. So, the group comprised of me, Nasuha, alongside Noor Syakila Binti Mazmin and Noor Ainnatul Syakina. Okay, so the problem statement is, first, using HAB or perceptron and Adaline training algorithm, construct your own classifier to solve the linear problem below with 100% accuracy. Training sequence will be from top row to bottom row. Second, retrain the data using HAB or perceptron and Adaline algorithm using different training sequence. For example, from bottom row to top row or other random sequence. Analyze your finding. Okay, so part 1, the training sequence will be from top row to bottom row. So these are the data that we have been provided with. The class that we have is class A and class B, and there are also x1, x2, x3. Okay, next. Okay, the first method that we will use is Hebbian learning algorithm. Okay, Hebbian learning rule is one of the first and also easiest learning rules in the neural network. It is used for pattern classification. It is a single layer neural network. Hebbian rule works by updating the weights between neurons in the neural network for each training sample. It is also used to implement OR logic gate with HAB. Okay, so the steps for HAB learning algorithm. First, we have to set up the neural network model by initialize weights W and bias B, set learning rate and threshold value. So for our assignment, in total there are 3 W, and we have set it so that W1 is equals to -3, W2 is equals to 0.2, W3 is 0.3, B is equal to 0.5, and threshold value is equals to 1. Second step is set activations of input units. So basically we will set it so that learning rate is 0.5. Okay, third step is compute response of output unit. So S is equals to B plus X1 W1 plus X2 W2 plus X3 W3. Y is equals to 1 if S is the same or more than theta value, and Y is equal to 0 if it is less than theta value. Okay, the last step is update weight W and bias B if an error occurred for this pattern. So basically for this learning algorithm, we will use Y is equals to T. As for the new W value, we will use the formula W new is equals to W all plus N multiplied by Xi multiplied by Y. As for B new, we will use the formula B all plus N multiplied by Y. So for my part, the sequence will be from the top to bottom, meaning like from top will be class A and then continue with class B, as we can see here. Okay, so for our W1, W2 and W3, we have set it up to be -3, 0.2 and 0.3. As for B, we set it up so that it is 0.5. Okay, after that, we will have to determine the value of W1, W2, W3 and B for the new ones. Okay, as for X1, X2, X3 and T, they are already given from us for us from the questions. Okay, so we basically just put that value into the table. As for Y, for Hebbian, the value of Y is equals to T, so we just copy directly the same. So in order for us to get the new value of W1, W2, W3, we will have to use this formula, which is W new is equals to W all plus N, which is in our case N is equals to 0.5 multiplied by I, which is X that is related to the W. For the one, the related one is X1, and multiplied by Y. So basically we will use this formula to get W1, W2, W3. Okay. As for B, for us to get the new value of B, we will use the formula, which is B new is equals to B old plus N multiplied by Y. Okay, so after that, after we have used this formula, we'll be able to get the end result, which is -3 for W1, W2 is 0.7, W3 is 0.8, and B is 2. Okay, after we have obtained this, we will use this value again. Okay, now for this table, this is used to determine whether or not the resulting table is correct or not. So from this, we will obtain the value of y prime, which is equals to x1 w1 plus x2 w2 plus x3 w3 plus b. Okay, so basically for y prime, if the value of y prime is more or the same as 1, which is the theta value, we will get t is equals to 1. But if y prime is lesser than 1, we will get the t value is equal to 0. So from here we can see that y prime equals to 2.5, 2.7, and 2.8. We can see that t is equals to 1. But for the later part, which is y prime equals to 0.5, negative 0.3, and negative 0.2, we can see that t is equal to 0. Okay, so that is that. Okay, so for this table is for us to find the data for us to plot in Matlab. So basically, from this equation, which is x1 w1 plus x2 w2 plus x3 w3 plus b is equal to or more than theta value, we will insert the value of the latest value that we get from the Hebbian training algorithm, which is this one, the in the yellow part. So we will insert the value into this equation. So basically we will get x3 equals to negative 1.25 plus 3.75 x1 minus 0.875 x2. Okay, so from this equation, we will determine the value of x3. So basically, x1 and x2, we will give the value to them. So in this case, the value of x1 and x2 will be from negative 3 to 3. So we will insert both of the value to the equation, and then we can get the value of x3. So all of this data will then be used in order to plot our graph. Okay. And now we will move on to the Matlab part. Okay, so for the Matlab, this is the coding, so we will go through it one by one. Okay, so for this x, we will put the coordinate of x that we have obtained earlier. So x is negative 3, negative 2, negative 1, 0, 1, 2, 3, 0, 0, 0, 1, 1, 1. Okay, so this obtained from, okay, let us see. Okay, x1, right, earlier. So negative 3, negative 2, negative 1, 0, 1, 2, 3, which is the same as this part. Okay. As for 0, 0, 0, 1, 1, 1, we obtain this from this part. Okay. So the next one is y. Y is equals to x2. So we will take the value from x2 at the table. So for x2, we can see that we have negative 3, negative 2, negative 1, 0, 1, 2, 3, as well as 0, 1, 0, 1, 1, 0. Okay, so this is the same that we have here. Okay, so basically we will take the value that we obtained earlier. Okay, so for z, z is equals to x3. So x3, we will see the coordinate is negative 9.875, negative 7, negative 4.125, negative 1.25, 1.625, 4.5, as well as 7.375. Okay, this, as you can see, is the same throughout this. As for this, 0.01101 is the same as the one that we get from x3. So, after we have list out all the coordinates, we will input the scatter tree because we will want to make a scatter graph. So the parameters will be x, y, z. So for the x level, we will label it as x1. For y level, we will label it as x2. Z is as x3. So the title of the graph will be 3D scatter plot. Okay, so let's see the 3D graph, which is, here you go. Okay, this is the graph. So so we can see here is the graph. So since it is in 3D, which have 3 axes, x, y, z, we can see that no matter which direction that we choose to see it from, it will still we will still be able to see it clearly. Okay, so here we can see that x, y, z is 0, 0, 1. Okay, where do we obtain this? Let's see. X, y, z is 0, 0, 1, which is this. For the value of this one. Yes, this is the one. Okay. For, let's see other value. So let's see, do we have another one? Okay, xyz is equal to 1, 1, 1. So xyz equal to 1, 1, 1 is this one. Okay, so from here we can see that these data are already in our table. So we can safely say that we are able to obtain this graph by using these values. So that is all from me. Thank you.
Assalamualaikum and good day everyone. My name is Noor Syakila Binti Mazmin. I'm going to presenting the Adaline training algorithm for the part 1. So an Adaline is a single neuron model which uses a linear activation function. This method can be used instead of hard limiter used perceptron model. So Adaline are implement or logic gate. And then we are going to next first step for Adaline training algorithm. So the first step is set up the neural network model by initialize weight and bias, set learning rate and threshold. So we are set W1 equal to -3, W2 equal to 0.2, W3 equal to 0.3, B equal to 0.5 and theta equal to 1. And second, set the activation of input unit. Third step is compute response of output unit, which is S equal to B plus S1 plus S2 W2 plus S3 W3. And then update weight and bias if an error occurs for this pattern. So W new equal to WO plus N multiply T minus S multiply with X. So B new equal to BO plus N plus and multiply with T minus S. So next, so this is the table. We already calculate for all the value. So this is the random initial value that we set. And to find the W1 here at the iteration 1, we just need to use this formula, which is W new equal to WO plus N multiply XI multiply T minus S. So we just need to get WO from here, from the initial, and then N is equal to 0.5 and XI is from here, which is if we want to find the new W at W1, we use S1. So T minus S, which is S, is the sum of value at the initial input. So we will get 0.5, which is the sum here is 0 plus 0 plus 0 plus B. So the sum is 0.5. So to find the T minus S, 1 minus 0.5, we will get 0.5. And then after we substitute all the value that we get inside this formula, we will get the new weight for at this iteration is -3. So for W2 and W3, we just repeated the step. And then for the B new, we use this formula, which is B new equal to BO plus N multiplied with T minus S. So BO, we use the bias from the initial input. And then the N is the activation that the learning rate that we set 0.5, and T minus S is from here. And then we will get the answer is 0.75. For the next iteration, we just repeated the step. And then here is to find the sum of. So this is the last result that we get for W1, W2, W3, and bias. So we use all these data, substitute inside this formula, and then to find the sum of for every iteration here, we just need to substitute the value of x, and then we will get the answer. So we need to choose the lowest value at the class A and class B. So the lowest value at the class A is 1.29375, and then the lowest value at the class B is -0.35. So next is select the theta higher than -0.35 and lower than 1.29. So as we can see, we need to select the range between lowest class A and lowest class B. So then we select the half theta, which is -0.35 plus 1.29 divided by 2, and the theta is equal to 0.47. And we use this formula, and then we substitute the value of W1, W2, W3, and bias, and then the theta from here, and then we rearrange and become the equation for S3. And then we just need to substitute the value of x1, x2 inside this equation to get the value for the x3. Next is plot data scatter plot using Matlab. So here, x here is x1 and y is x2, z is x3. We just need to put all the data x1 here and all the data for x2 here and all the data for x3 here. And then we can see the plot graph for the plot scatter for this Adaline part 1. So we can see the graph is linear activation function. So that's all from me. Thank you.
For part 2 is training sequence will be random, which is the arrangement of class A and class B is random, AB, ABB. So the value of T also change due to these changes. Okay, first for Hebbian learning algorithm. Okay, as we can see the table from the table. Okay, first we see the value or the initial value, which is W1. W1 is -3. W2 is 0.2 and W3 is 0.3 and the bias is 0.5. So then we have to calculate the value of this row using these two formula. So for this one, for value of W, we use this W all plus NXY. So for the value of W all is the value that the upper column for this value, and for X, since this is the column for W1, so the X is X1 and Y is 1. So we get the -3. So same goes to W2 and W3. For the value of bias, we use this formula, which is Bn equal to B alt plus Ny. So B alt, we use this column 0.3, 0.5, and N equal to 0.5 also, and Y is 1, then we got 1. The calculation will have to calculate by row, not by column, until the last row for the class, which is this column. So this is the value of the last value for W and B. Okay, next, this column we have to find the Y1, Y prime. To find the Y prime, we use this formula: x1 W1 plus x2 W2 and plus x3 W3 and plus B. So we substitute the value of x and the value of W here and B. So first we get the value of 2. Okay, for we know that theta is equal to 1, so the value of 2 is considered for 1 because it is bigger than 1, so it's 1. And same goes to this 2.8 is 1, negative 0.3 is 0 because it's lower, it's smaller than negative 0. And it is lower than 1, and 2.7 is 1, 0.5 is 0, negative 0.2 is 0. So that means we get the 100 accuracy. Okay, next, this table is for the plotting graph at Matlab. So we use this formula: x1 W1, x2 W2, x3 W3 and B. And we substitute the value of W1 that we get from the table. Okay, after that we get x3 equal to 3.75 x1 minus 0.875 x2 minus 1.25. So value of x1 and x2, we assume that this is the value: negative 3, negative 2, negative 1, 0, 1, 2, 3. Use this value and we get the value of x3. So this is the coding for the Matlab. X is referred to x1, y is x2, z is x3, and this is for label for the graph and the title. Okay, this is the 3D graph, 3D scatter plot. As we can see, there is the straight line that separate the point for class A and class B. So we can see from the Matlab. Okay, this tree. Okay, so we see it is 1, 1, 1. and 101 and 110. So this value is for class B and this is class A. 001, 000, 010. Okay. So that's all for the Hebbian algorithm. Okay, next is Adaline training algorithm. So for the table Adaline, we add the sum and t minus sum. So the formula for sum is x1w1 plus x2w2 plus x3w3 plus b. Okay, first we see the initial value, which is same with the previous one, negative 3, 0.2, 0.3, and 0.5. And the value for the row here and until the last row is same with the previous one using this formula, but the difference is we have to calculate the value of sum. So to calculate the value of sum, we have to finish the row here and then we can calculate this sum at this row. So we substitute the value of w and b at this formula and then we get 0.5. So for this value 1.05 we get from this row, this value negative 3, 0.2, 0.3, 0.75, and same goes to this column until the last one. Okay, then for this as usual we have to find the y prime using the same formula, which is x1 w1 and x plus x2 w2 plus x3 w3 and plus b. But we have to choose the value of the lowest value for class A and the lowest value for class B to use for the next step. Okay, and the accuracy, we get 100 accuracy based on the value, and then okay, from that value we get the from the lower and the from the lower value for class A and class B, that this one we have to plus that value and then divide it by 2 to get the data for this. And then we have to use this formula to plot the graph at Matlab, and use this formula x1w1 plus x2w2 plus x3w3 plus b. So after we substitute the value of w1, w2 and w3 and b for in this formula, we get x3 equal to negative 0.9641 plus 2.955 at x1 minus 1.02762 x2. So we substitute the value of x1 and x2 here into this formula to find x3, and then we get this value. So to see the coding, this is the coding. Okay, this is the value of x, and this is the x001011. So this is for x1, y for x2, z for x3, and this is for label and the title. Okay, for this is the the straight line for this scatter plot to spread the class A and class B. So we can see a Matlab here. Okay. This one. This is the this is for class B, which is 101 and 110, and this is for class A. This okay, 110 for B, 110 and 101, and for class A 00, 001, 000 and 010. So that's all for the Adaline algorithm. Okay, last one is for discussion. First, Adaline and Hebbian are singular neural network models. Hebbian is one of the first and also easiest learning rules in the neural network. Hebbian used for pattern classification, and Adaline uses continuous predicted value to learn the model coefficients, which is more powerful since it tells us by how much we were right or wrong. Adaline is more accurate. It will tell the user if the Adaline or perceptron is not suited for the given set of input patterns, because the Adaline will keep on updating its weights and never stop if the Adaline or perceptron cannot categorize the input patterns. Thank you. That's all from our group for the neural network.